Welcome to the DIY Honda Garage channel. DTC P1549 indicates an issue with the charging system in the Honda Odyssey models from 2011 to 2017, specifically relating to high voltage levels within the system. This problem can occur due to various reasons, including a malfunctioning alternator. The alternator is responsible for generating electrical power and charging the vehicle's battery while the engine is running. An inline battery monitored at 24 volts can also trigger this code, pointing towards discrepancies in voltage readings. It is crucial to capture freeze-frame data and onboard snapshots prior to starting the troubleshooting process, as this data provides essential context for diagnosing the issue. Understanding the interplay between these components is fundamental for an effective repair strategy. Proper diagnostic tools like the Honda Diagnostics System, HDS, are needed for accurate fault isolation. DTC P1549 is directly associated with high voltage levels in the charging system of the Honda Odyssey. The alternator, typically located near the front of the engine, serves as the principal component for converting mechanical energy into electrical energy. When the engine is running, the alternator creates power that not only charges the battery, but also powers the vehicle's electrical systems. If the voltage generated exceeds normal limits, this can lead to high voltage faults like DTC P1549. Furthermore, high voltage batteries connected to the vehicle at 24 volts can lead to erroneous codes, as they can cause the onboard diagnostic system to misinterpret voltage levels. Therefore, proper evaluation includes first verifying the vehicle's voltage inputs and ensuring that the components function within their specified parameters. The most common cause of DTC P1549 is a malfunctioning alternator. This component must be operational to maintain appropriate voltage levels within the vehicle's charging system. If the alternator fails to generate the correct amount of current, it can produce high voltage readings, triggering the fault code. Another potential trigger is the presence of a high voltage 24-volt battery connected to the system, which can mislead diagnostics and show high voltage errors. Additionally, poor connections or loose terminals at the alternator or the underhood fuse/relay box could contribute to this fault, leading to inadequate electrical pathways and erroneous voltage readings. Each of these causes must be systematically assessed to accurately diagnose and resolve the issue. When DTC P1549 is triggered, one noticeable symptom is the illumination of the check engine light on the dashboard, alerting the driver to a potential problem. Electrical system malfunctions may also arise, manifested as erratic behavior of various components such as lights and infotainment systems due to inadequate or excessive voltage levels. Another symptom can include issues with battery charging, where the battery may either fail to charge properly or overcharge due to erroneous electrical inputs. These symptoms together create challenges that not only affect the drivability of the vehicle, but can also pose further risks if the issue remains unresolved, such as damaging sensitive electrical components. Begin the troubleshooting procedure by turning the ignition switch to the on-to position. This action activates the electrical systems without starting the engine, allowing diagnostic tools to communicate with the vehicle's onboard computer. Next, clear the DTC using the Honda Diagnostics System, HDS, ensuring that any previous faults are reset before proceeding. This step is crucial for isolating current conditions and determining whether the DTC is persistent or intermittent. Following the DTC clearance, start the engine to allow for real-time monitoring while the vehicle operates under standard conditions. These steps provide a clean slate to identify whether the same or new DTCs are generated during the following tests. Next, confirm that the vehicle is operating under specific conditions crucial for testing. The air conditioning should be off, headlights should be off, and the rear window defogger must also be disabled. These parameters are essential to eliminate additional loads that can influence the voltage measurements. With these conditions verified, hold the engine speed at 2,000 revolutions per minute, RPM, while the vehicle is in park or neutral, N, for 1 minute. This steady RPM helps to stabilize the current output from the alternator, allowing for accurate readings of the vehicle's electrical system performance. It lays the groundwork for subsequent voltage measurements to identify if the DTC P1549 reoccurs. After holding the engine speed constant, utilize the HDS to check for any pending or confirmed DTCs that may be present. It is essential to assess whether DTC P1549 is indicated, which would suggest that the issue persists even after clearing and running through the initial diagnostics. If DTC P1549 does appear, it reinforces the diagnosis that the alternator may need to be replaced, as the problem is confirming a continuing high voltage condition indicative of a failing component. On the other hand, if DTC P1549 does not appear, it implies that the fault may be intermittent, and thus all connections and terminals associated with the alternator and the underhood fuse/relay box should be inspected thoroughly. If it is determined that DTC P1549 is present, the next step is to replace the alternator. The alternator is a vital electrical component, and its failure can lead to inadequate voltage regulation within the system, causing high voltage conditions and potential failures in electrical components. After replacing the unit, it's critical to continue with the next steps to ensure everything is functioning as intended. Before concluding any repairs, confirm the integrity of the entire electrical system, including the connections and terminals that may have contributed to the initial fault. This allows for comprehensive verification that all issues have been adequately addressed, supporting the longevity of the repairs and the vehicle's reliability. With the new alternator in place, the ignition switch should again be turned to the on-I position, preparing the system for further diagnosis. Utilize the HDS to reset the powertrain control module PCM. The PCM is the computer responsible for monitoring and managing engine functions and electrical performance, and resetting it is crucial after any component replacement. Following the reset, conduct the PCM idle learn procedure. This procedure is vital to allow the PCM to recalibrate to the new alternator input, ensuring the engine management system can optimize performance under the new operating conditions. These actions set the foundation for ensuring that the vehicle runs smoothly after repairs and confirms all changes have been appropriately registered within the system. Following the reset and the idle learn procedure, start the engine once more to initiate the final round of diagnostics. Again, check to ensure the vehicle operates under the same conditions as before. The air conditioning should be off, headlights should be off, and the rear window defogger must be disabled. Maintaining these requirements ensures that no additional electrical loads affect the readings. Then, hold the engine speed at 2,000 RPM for 1 minute. This step replicates earlier conditions where the system can be monitored effectively, allowing the newly installed alternator to generate voltage levels that can be accurately tested for anomalies or confirmations of DTC P1549. After maintaining the engine at 2,000 RPM, it's necessary to use the HDS again to check for any pending or confirmed DTCs that may arise. If DTC P1549 is indicated once more, this suggests that the underlying issue has not been resolved, necessitating a deeper dive into the connections and terminals associated with the alternator, as well as the underhood fuse relay box. Poor connections can lead to inadequate electrical continuity, resulting in high voltage readings. Therefore, a thorough inspection of these connections becomes paramount before taking any additional steps. Should DTC P1549 not display again, it would indicate that troubleshooting is successful, affirming the efficacy of the repairs made. To conclude the troubleshooting process, carry out a final verification to confirm that the repair has been successful. This includes testing the vehicle under various conditions to ensure that DTC P1549 does not return. If any new pending or confirmed DTCs appear, it is crucial to address these before considering the troubleshooting complete. Each DTC should be reviewed in relation to the recent repairs made to ensure all aspects of the vehicle's electrical systems are functioning correctly. Verifying system reliability also means monitoring the performance of the new alternator, battery, and connections over time, crucial for the longevity of the repairs made and avoiding future issues. Preventive maintenance for the Honda Odyssey's charging system is vital in avoiding future issues related to DTC P1549. Regularly inspecting the alternator helps to identify any performance drops that may occur due to wear or electrical faults. Checking the connections and terminals ensures they remain tight and free from corrosion, which could otherwise lead to poor electrical performance and triggering fault codes. Additionally, keeping a close eye on the battery condition, including its charge state and age, can preempt prematurely triggering DTCs that indicate charging system failures. Engaging in these preventive measures promotes the long-term health of the vehicle's electrical system and contributes to reliability. In conclusion, understanding DTC P1549 is essential for effectively diagnosing and repairing high-voltage issues in the Honda Odyssey. The systematic troubleshooting steps provided are designed to clarify the path from diagnosis to resolution, focusing on key components such as the alternator and electrical connections. Implementing preventive measures helps maintain the reliability and performance of the vehicle's charging system, thus preventing the recurrence of such issues. Additionally, regular inspections and upkeep of electrical components can significantly enhance the longevity of the system. Lastly, employing the right diagnostic tools like the HDS is paramount to accurately identify and rectify problems within the charging system. Please like and subscribe to the channel. See you next time.